So we're now going to talk about the layers that are involved in starting a thread. As I mentioned before, this whole lesson about thread life cycles really focuses primarily on starting and stopping. So we're going to begin, of course, with starting, and we'll see there's a bunch of layers involved in starting a Java thread. And starting a Java thread involves a bunch of very interesting design and implementation issues. So the first thing to note is when we call start on a thread, that will create the runtime stack and other resources that the thread needs, such as registers and thread-specific storage and so on. And then at some point, once the scheduler selected that thread to run, it'll start to run, and its run hook method will get called back. Now, what's really happening under the hood, of course, is that the Java platform, or the Android platform if you're running an Android, has a whole stack of layers that provide a bunch of different mechanisms to run concurrent programs on a wide range of computing devices, all the way from very small wearables or handheld devices like a smartphone or a tablet up to larger devices, such as a laptop or a desktop or even a server. If you look at these different platforms, you'll see that there's obviously implementation variations between different versions of Java running in different versions of Linux or Windows or other operating systems. Android behaves a little differently. And even though they're all slightly different, they have very common layers of abstraction or levels of abstraction. So in particular, just to focus on Android, because that's what we're using for our development for the course, it provides a stack of layers that define various mechanisms to run concurrent programs on mobile computing devices, again, like smartphones and tablets and wearables and so on. And you can see here that the Android Linux kernel, like any operating system kernel, controls the underlying hardware resources, most importantly, the processor cores, and also manages other system resources like virtual memory and networks and other kinds of things. Up a layer, we then have something on Android called the Bionic libc library. Libc is the standard C library, and this supports the famous pthreads C programming API. And the API for pthreads essentially allows for C-level programs to create a thread, to send interrupts to a thread, be able to do various things to suspend and resume the thread and get its status and so on and so forth, join with it and whatnot. And that's what's used under the hood, as we'll see a little bit later when we talk about the internal workings of threading in Android. Then there's also execution environments. On Android, for example, there's Dalvik, which is the original interpreter, and more recently there's the Android runtime that provide a managed execution environment for Java apps and other apps. And so there's interesting things taking place in that context. In particular, there's threading abstractions that are implemented as part of the Java virtual machine. And then there's also something at this layer that's very important in Android, which are the runtime classes from the Java util concurrent packages. So Dalvik or Art would provide the basic thread implementation, and then the Java util concurrent packages would provide essentially Java-centric wrappers around the thread implementation, which is typically done in a lower level, as we'll see when we walk through the code. So the key point of this is that starting new threads or creating new threads, starting them and stopping them and so on, consumes a non-trivial amount of system resources. So make sure you use threads judiciously. In particular, you should only create threads if you have computations that run a lot longer than the time that's needed to spawn or to launch them. So for example, spawning a thread to stream a video might be a good use of threads, arguably, or to do anything that involves long-running network computations or maybe I/O computations. Conversely, spawning a thread that's going to swap two numbers is complete and total overkill. There's no need to do that. You can just swap the numbers. There's really no good reason, unless maybe you have swapping two big integers that are, hundreds of thousands of decimals in precision or something like that. But even then, it's probably overkill to do a thread in many cases for things like that. So this was a quick overview of the layers that are involved in starting a thread. The next part of this lesson will then look into the actual implementation details of starting the threads and show the chain of method calls that are invoked for different levels in the Android platform.